Alright, so when it comes to basic mechanics and then we are doing anything of resultant forces or statics, right? Or yeah, statics of this sort. One important thing is that like you have to get some kind of guide or procedure you follow, right? So here's an outline. Generally, doesn't mean you should necessarily follow this every time you are solving it, but have this at the back of your mind that whenever you are solving questions of this sort and then you see this, the best way will be to follow something like this in order to help you know what you need to get where you are going, right? So when you get this, read the question, right? If there's a diagram, fine, continue from there. If there's no diagram, fill in the diagram and know where to continue. So they are saying it's a cable AB and AD, right? And there are tensions in them, right? Tension in the cable AB is 120, so let's put it there, 120 newtons, right? And then tension in the AD cable is 40 newtons, right? Right. So here is the case that they've given us the diagram and everything we need already, right? So we are still on the diagram, though it's not complete. We can see we are still working on our diagram. Okay. Uh-huh. What are, what are they asking you to find, right? They're asking you to find resultant force, resultant of the magnitude of the forces at this point here, right? And we know that since there's tension in this rope, tension meaning that we are stretching it, right? So it's going somewhere like this, and then the same thing here. And since these two forces are come to act at this point, there will be a resultant force, right? A resultant force. So it can be something like this. So we are still working on our diagram. So let's see. So we can end up getting something like this. When we bring everything together, meaning we are getting something like this. Then one thing again is that when it comes to this resultant of forces and stuff, when we are trying to solve questions of this sort, it's very important that before you find a resultant force you need angles, right? In this case we only have magnitude of the force, we don't have any other angles. So what we do is that they've given us other information. You see, other side they've given us this and then this. So here's where our trigonometry plays part, right, to help us get our resultant force. So this can be a resultant force. Let's just write it here, right? Yes, resultant. Okay, so if this is a resultant and then they've given us these sides, right? So looking at this diagram again, you can see that this is just to help us understand. It has been, we can divide it somehow, right, to get two triangles. So it could be something like this, where we have this 120 here, right, and then a side, and then there's the R, right, and then we have a side here. We know from here to here is 10 centimeters, right, and then here is what, 8 centimeters, and then we have another triangle the same length, right? Then again, when you are doing it, it's not necessary that you write everything that we are doing here, but let's just get the understanding so that when you are writing or when you are solving questions of this sort, you get to speed up, right? You know where you are going, you have what you need, and then you just move straight forward, right? So let's make this angle here alpha, here is beta. If I'm trying to find this alpha here, in order to find a resultant, because it's here, in order to find a resultant, you see that you have to redraw the whole thing again. You could use the triangular rule or parallelogram rule. So suppose we use a triangular rule of this sort, okay, of this sort, meaning that we'll need the angles, right? So that's why we are after the angles right now to get our resultant force, right? That's what we are doing. We are trying to get this angle here. So you see, this is what we did here, and then we separated to this to get the alpha and beta, right? So in order to get the alpha, this is what we do. There's an angle here, so this is our opposite, right? And this is our what, our adjacent, right? This 10 here is for this side and then this side. So to get the angle alpha, we need tan, right? So tan inverse of what? Opposite, right? Over adjacent. That will give us our angle, right? And then for beta, what will that give us? Tan inverse opposite, which is this, right? 6. Adjacent is what? This 10 again, right? So that will give us our beta too. So let's see what we have for those ones. Another thing too is that when you're solving questions of this sort, it's best if you just write whatever you need and use a calculator to punch everything at once, because you know what you need to get the answer, right? So let's see, tan inverse of what? 8 on 10. What I get? 38. And then questions of this sort, it's best if you set your calculator to 2 dp at the very least. Okay, we don't know what could happen in the answers that are available. Degrees, right? And the beta, that was 6. Or that'd be 30.96 degrees. Okay, now we have these two. So now that we have these two, we still have our diagram here. So let's just put it here. We know alpha, we know beta already, right? So if you try to turn all this into a triangle, this will happen. Let me see. Let's do this here. So alpha, here's beta, right? So if you try turning this into a triangle, you can choose anyway. But if you put the 120 here, and then there's the resultant here, right? The resultant. Right? This was initially here, so we are trying to make something parallel to it. So here, right? So that's our 40 newtons, right? Here's our 120 newtons. The diagrams are very important. So then this is what we have now. But from this angle, from this particular triangle here, when you compare this one to what we have here, now we have to do what we have, right? So the alpha is already here, straightforward, right? The beta was here, right? We know the beta is the angle that this one, if there's the beta here, we know it's the angle that it makes with this r, right? So it's the same thing. So we're having this, let's extend this so we see what's happening, right? So there's a line, there's it, right? The 40 newtons. There's the r. So there's the beta here, right? So if beta is here, meaning that we have our beta here, right? Directly opposite angles, right? So before we can find this r here, we need this angle here, right? If you try to use the cosine rule, right? So to get the angle there, this angle in the triangle is 180, so that will be 180. The angle that is here, let's say gamma, right? This gamma here is equal to 180 minus alpha minus beta, right? So what that give us? Let's see. $180, right? And then before you even choose the procedure you follow for a question, it's very good to visualize everything before you even do anything at all. So A is what? 38.66, right? And then we have 13.96. So 101.41, right? 110, sorry, 0.41 degrees. That's our gamma. So we have it here, right? And the cosine rule is something like this. And then we have 120 squared plus, it's actually Newton, sorry. 120 plus 40, right? Minus 2, 120 times 40, right? And then we have cos the angle, this one, this gamma here, right? So that gives us our r squared. Let's see, 120 squared, 120 squared, right? These are squared, plus 40 squared minus 2 brackets 40 times 120, right? Cos this angle, which is 110.41, right? Here's what I get in 19347.86. It's very important that anytime you do things of this sort, you have to remember what's here. Also, if you forget to get rid of this 2 here, your answers will be way out of the line, right? So remember where you are going and what you need. So in order to get this R, you do square root of our answer, right? Okay, this is our answer. Okay, let's just do it straightforward. Square root of 19,347.86, right? What is that giving us? 96.68 newtons. Wait, there's something wrong. 19, so there's it. So whenever you start a question, know what is there, like the information they are giving you, right? What they're asking you to find, and then how you are going to get what they're asking you to find. Are we okay? Well, the moment you have that in mind and you are doing any questions of that sort, you know where you are going, right? So let's see if we are getting the answer they got. Okay, 139, just a difference of 0.06, right? Yeah, so that's it.